Hi everybody, this video is going to focus on how we write equations for lines when we don't necessarily know the slope or the y-intercept of the line. So it's a little more complicated, and this is one of those big topics, those big things in algebra that we need to do fairly frequently. So we've been working a lot with slope-intercept form, which is our y equals mx plus b format. But another one that we use pretty often is something called point slope form, and it is given by this. Y minus y1 equals m parentheses x minus x1. Now m, just like it always has been, is our slope. So to use point slope form, we need to know the slope of the line. And then we also need to know a point on that line. So the x1, y1 you see here is just any point that is on the line that we're trying to write an equation for. Okay, so this is a point on the line. Now you'll notice that my equation also has a y and an x that do not have a subscript. Now we're not going to plug any numbers in for those. Those are the y and x that should stay in our equation just as y and x. So let's look at how we can use this. Okay, let's say I have a line and I know that it has a slope of 2 and that it goes through the point, or has the point 4, 1 on that line. We want to write an equation. Okay, in the past we were given, or could easily find, the slope and the y-intercept of that line. Here we know the slope, but we don't know the y-intercept. We know a different point. So whenever you have a point and the slope, you use your point slope formula. Y minus y1 equals m times x minus x1. So let's start by labeling. Slope is really just m. Okay, and I label my point x1, y1, and then I make some substitutions. I do y minus y1, which is 1, equals m, which is 2, parentheses, x minus x1, which is 4. So I just plugged everything in. Now, typically, even though we're starting off in point slope form, we want to write our final equation in slope intercept form, which means I need to get y by itself. And I also need to distribute this 2. So let's just think about this as an equation. On the left side, we still have y minus 1, but when I distribute that 2 here, I get 2x minus 8. And then to solve for y, to get it by itself, I need to add 1 to both sides. So after doing a little bit of work here, I can get y equals 2x minus 7. So now we have an equation in slope-intercept form. Even though we were given the slope and a point, we were able to do this process to figure out what that y-intercept would be, and it also makes the graphing process a little simpler. So let's look at another example here. We have a point, x1, y1, and we have our slope. So again, if we're given slope or given a point, we're using our point slope formula to write the equation for that line. So we're going to do y minus y1 equals my slope, parentheses, x minus x1. So you can see I'm just making simple substitutions here. Okay, now we want to distribute the 1/2. So we have y minus 4 equals 1/2 x. Okay, and then 1/2 times -2 would be -1. And then to get y by itself, we just need to add 4 to both sides. So now we have y equals 1/2 x plus 3. And again, we didn't start in slope-intercept form. We start off in point slope form. But when we distribute and then solve for x, or I'm sorry, when we solve for y, we get our final equation written in slope-intercept form, which is probably the most common that we use throughout the year. Now, the big thing that can really mess you up when you're doing this is you have to be really careful with the negatives. So if you're one of those people that loses track of negatives really easily, you're going to really have to pay attention here. So if we go through this process, we have our point, we have our slope, we're using the point slope formula. When we go to do y minus y1, we're good. We put our slope in, and then we do x minus x1, but here's where we need to be extra careful. If I do x minus x1, you'll notice that I'm subtracting a negative. Okay, and anytime you do that, you have to be super careful. If I'm subtracting a negative 6, I'm going to immediately rewrite this as x plus 6. Okay, don't try to save yourself the space. Just rewrite the whole thing so you don't mess up. On the left side, I have y minus 0, which is really just y. Okay, so at this point, it's solved for y, which is nice, but it's not in my slope-intercept form yet because we need to distribute. So when we distribute, we get y equals 2/3 x, and then to do 2/3 times 6, we do 2 times 6, which is 12, and divide by 3, so we get plus 4. All right, and then another example here. This time, both of our x and y values are negative, and our slope is also negative. So we're going to have to be extra careful when we're plugging things in. So we have y minus y1 equal to our slope, parentheses, x minus y1, or I'm sorry, x1. So I'm going to rewrite this. Y minus negative 1 is the same as y plus 1. X minus negative 8 is the same as x plus 8. Okay, once I do that, now I'm ready to distribute. So y plus 1 equals negative 3/4 x, and then negative 3/4 times 8. Okay, so negative 3 times 8 is negative 24. Divided by 4 would give us a negative 6. Now our last step here is just to get y by itself, so we can subtract 1 from each side, and we get y equals negative 3/4 x minus 7. So this is if we have the points and the slope given to us. Now, we won't always be given the slope. Sometimes we'll only know 2 points that are on the line. We don't know the slope, so we need to start by using our slope formula, which we've used previously, to actually find the slope between those 2 points. And then what we're going to do is we're going to take that slope that we find, and we're going to use one of the points that we knew, and we're going to plug that into our point slope formula to actually get our equation. So let's see what this looks like here. Okay, so maybe all we know about a line is that it goes through these 2 points. Anytime I'm writing a line, the first thing we need to do is find the slope of that line. So let's go ahead and label our points x1, y1, x2, y2. Now, to find my slope, and I'm going to label my work here since there's going to be a lot of it. To find my slope, we said we're going to use that slope formula. So m equals y2 minus y1 over x2 minus x1. We simplify. So negative 1 minus 7 is negative 8. 1 minus a negative 3 is really the same as 1 plus 3. So we get negative 8 over 4, and if we divide, we find that our slope is really negative 2. Okay, so there's the first important piece of information. Now, we're going to take that slope that we just found, point slope form, along with one of the points that we started off with, to actually write our equation. So I'm going to write down what I know. I know the slope is negative 2. I know that my line passes through these 2 points up at the top of our problem here. But even though I label negative 3, 7 as x1, y1, I don't necessarily need to use that as the x1, y1 in my point slope form. I typically choose whichever point has the smaller numbers. So in this case, 1, negative 1 is what I'm going to use as my x1, y1. And even though it's already labeled as x2, y2, that was specifically just for our slope formula. We're allowed to change which point we use, or just pick one of those points, I should say, when we're using our point slope form. Regardless of the point I choose, I'm going to get the same equation at the end. So it really doesn't matter. So let's plug it in. We've got y minus y1 equal to the slope times x minus x1. Okay, so let's change this to y plus 1 here. Let's distribute. And then to get y by itself, we just subtract 1 from each side. So we get y equals negative 2x plus 1. Now, I want you to notice here that we started off in point slope form. But again, we solved, and our final product, our final equation, is in slope-intercept form. So I'm labeling and numbering these things so that you can see the process, because we use every single format and formula that we've had this year. So our final equation, y equals negative 2x plus 1, is in our slope-intercept form. So when we're given 2 points, this is the most work you can do for one of these problems. We have to start by finding our slope, taking the slope in one of the points, using point slope form, and then solving for y to get our final answer in slope-intercept form. All right, let's look at one more example here. So 2 points. We're going to start by labeling x1, y1, x2, y2. And again, we're going to start by finding the slope between these 2 points. So we use our slope formula. M equals y2 minus y1 over x2 minus x1. Now, I'm going to be careful here because I have lots of negatives and subtraction happening. So this is really negative 4 plus 7 over 3 plus 6. So negative 4 plus 7 gives me 3. 3 plus 6 gives me 9. 3 over 9 reduces to 1/3. So my slope that I'm going to use here is 1/3. And now we're ready for our second step. We're ready to use the point slope form. So we're going to take that slope we just found, okay, 1/3. We're going to use that with one of the points that we started with. Remember, choose the one with the smaller numbers. And we're going to substitute those values in to write the equation for this line. So I'm going to use 3, negative 4 as my x1, y1. So let's go ahead and plug it in here. We would have y minus y1 equal to the slope times x minus x1. Okay, let's go ahead and change this to y plus 4 since we're subtracting a negative. Let's go ahead and distribute that 1/3. And then to finish it off, we just need to subtract 4 from both sides. Now, our final answer, and I'm just writing this out to show you the connection between everything here. Our final answer is in slope-intercept form, and it's what we just found. Okay, y equals 1/3 x minus 5 is the equation written in slope-intercept form. All right, feel free to rewind, pause, and please ask questions if you don't understand. Hope you guys have a great day.